Welcome to our second project in Unit 3 on probability theory. In this project and tutorial, we're going to focus on building a covariance matrix in R. We're going to do this in two ways. One, we're going to build the covariance matrix ourselves by calculating the expectation or mean, and then creating a difference matrix and moving on to the covariance matrix from there. And then we're going to compare those results to R's built-in covariance matrix functions. So let's go ahead and dive right into that. We're going to start by opening up RStudio. And this is going to open up the project, Unit 3 projects that we had started before, since I still have that project open. And so we'll see our last project in there. We have this script, which was graphing distributions. Let's go ahead and create a new script. So a new R script. And in this one, we're going to be building the covariance matrix. So this is the project for the lecture on expectation, variance, and covariance. Hopefully we can take some of those concepts and put them to use. So let's add a comment at the top here. Building a covariance, spell our words right, covariance matrix in R. Two ways. Alright, so first things first, let us create some column vectors. So we're going to be working in a 5x6 vector. So we can just define these to whatever you want, really. So you'll use C parentheses 1, 2, 3, 4, 5, 6. That can be a good one. So we got to make 5 of these. A B. So let's say C, and we can have go by 2's this time. Let's not add spaces. There we go, that looks better. C, let's make one of these a lot larger. 10, 20, 30, 40, 50, 60. D, and again, feel free to use whatever you want. You don't have to use the same column vectors that I do. You can use your own values. Maybe throw in some funny ones, some very large ones, some very small ones, whatever you want. Alright, but here I have my 5 column vectors. If I do a Control-Shift-Enter, this will run this script. You see that we've defined these 5 vectors here. They all have 6 values, so that's perfect. They're all the same size. Let's go ahead and combine these and create a matrix from vectors. So to do that, we'll just call this matrix M. We use the C bind, and then we just pass it all of the vectors A, B, C, D, E. And we can also, we're going to need some variables here. We have K, which is going to be the number of columns of M, and then let's have N, which is going to be the number of rows of M as well. So this is essentially the size. Let's go ahead and Control-Shift-Enter. Now you see we have a matrix. If we actually print out this matrix, we'll be able to see it below. So print matrix, and here you go. Now you see the matrix in our console output that we have below. So here's the column vectors that we defined. This middle one, very large. Outer ones, not that big. Okay, so there's that. Now what we need to do is find the mean for each column. So the mean here is essentially the expectation. We'll call this k-mean, and it's going to be, use this command. So matrix data equals 1. So just a matrix of values of 1s with the number of rows equals n. And then we're going to do a matrix multiplication, and that is denoted by this percentage asterisk percentage in R, matrix multiplication of C bind, mean of A, mean of B, mean of C, mean of D, and you guessed it, mean of E. Okay, so there's our means. Let's go ahead and print those out so we can show what those actually are. So run Control-Shift-Enter. And so now you see we've got a column vector since we did, or a matrix. Since we did this matrix multiplication, it's going to be the same size as our original matrix, and we have the mean of each column all the way down for the 5 rows, or 6 rows in this case. 5 columns, 6 rows. All right. From there, the next step in working towards our covariance is to create a difference matrix. So we'll call this diff of m. And to do that, we simply have m minus k mean. Since these matrices are the same size, we can do that very easily. And if we print this out, we'll see the difference. So this is a mean subtracted matrix. It's each individual value subtracted by the mean of that column. So looks good. And so that's actually all we need to create the covariance matrix. So let's go ahead and do that now. Create the covariance matrix. So we're going to use matrix multiplication again. We'll call this covariance of m. And what we're going to do is multiply n minus 1. So remember, n we defined as the number of rows up above. Inverse of that times t here, which is going to be the transpose of the difference matrix, multiplied by the difference matrix again. And this is going to be a sample-wise covariance. You can also do a population covariance. We're going to focus on the sample covariance here, since that's much more common. Print covariance matrix. Let's print that out. So if we run Shift-Enter, here we go. We have our covariance matrix. So see, we have some really small values. We have some negative values, some positive values, very large positive values. So as expected, we get back the covariance matrix. And remember from the lecture, what we can actually do is we can find variances from the covariance matrix. And that's actually really easy to do. The variance is simply going to be the diagonal of the covariance matrix. So we can print the variance. There we go. So very high variance for column C, which makes sense since these were our larger values. A step of 10 between each value in that column. Our outside ones are the same actually, because if you look, they are just integer steps of 1, so the spread is the same for both the A and E columns. So that makes perfect sense. Alright, so that is building our own covariance matrix. Now I'll show you what we could have done. And this is the power of R. It has built-in functions. We can simply call covariance and pass it. The COV is going to be the covariance command of a matrix M being our matrix that we made above. Let's go ahead and print that out, and we should get the exact same results, and indeed we do. So building our own covariance matrix, we get back the same values using R's built-in covariance function. So R has a lot of these built-in functions. It's really easy to do the math yourself if you know how to, or you know the formulas. But oftentimes R is going to have convenient built-in functions to do most of these mathematical transformations that you would need. So that's a quick introduction to covariance matrices in R. So hopefully this supplements the lecture and you can start to understand how some of these are found. And when it shows up in a paper on machine learning that you're reading in the future, you can have some understanding of what they are talking about when they mention variance or covariance or even expectation. So I hope you learned something today. Thank you very much for following along with me and building this project alongside me. I hope you enjoyed it. Have a good day.